and Ivan is going to give a presentation called Modularization precedes digitalization. Oh, it's a tongue breaker. Can you hear us?
Yes, can you hear me?
Yeah.
Let me share my, should I share my screen? Hello?
Yeah, yeah. We're
Okay.
waiting for you to share your screen.
Great.
Okay, we can see your screen.
Full slide?
Yeah.
Great.
Kind of.
Kind of. I'll take it. Well, thank you for having me. I wish I could be there in person. So I am Ivan Rupnik, founding partner of ModX. And today I'm going to be talking about some steps that need to be taken for CONTECH to deliver on its promise that we, as ModX, we've learned from other industries and want to bring into construction. So modularization precedes digitalization and industrialization in construction. So a little bit of background. ModX is a knowledge management company. It is a startup. Good guess there in the offsite construction space. The leadership team consists of Ryan Smith, who's an architect and a professor like myself, Ivan Rupnik, who I'm based between Boston and Zagreb, somewhere in between sometimes, and Tyler Schmetterer, who's our third leadership member and founding managing partner, who's based between New York and Geneva. So we're a US-based company that's also very international. What we do, we work in 3 nodes. We do executive education. We organize exchanges, which are essentially intensive research and networking events. And we do direct advisory work in the offsite construction space. So what we're usually talking about, and why are we usually talking about it? We're usually talking about offsite construction, which is a form of construction that I'm sure you're familiar with. Tends to work in factories. Why are we talking about offsite construction again? It's been around for 100 years. This is a photo from 1917 in the US. I know Lithuania also has had its experiences previous periods with offsite construction. Well, because construction has a problem, as you probably know, from the McKinsey Institute's report in 2017. Construction is the only industry that has not improved in productivity. And in fact, in the US, particularly, construction has lost productivity by as much as 50% from 1968. It is deindustrializing. Oh, sorry, too fast. And what we've noticed with our work in the space is that new players, particularly that come into the construction space, based partly on the work that McKinsey has done, look to technology and innovation and offsite construction to solve this without often going through some of the necessary steps to ensure that that technology delivers on its promise and that offsite delivers on its promise of increased productivity, efficiency, and quality. So in the US, for example, we have fairly high offsite construction market share. In the housing space, more than 10% of construction is highly industrialized, manufactured housing, which has been around for about 50 years. And volumetric modular housing have a significant market share of the industry, but have also stalled in terms of their expansion. And digitalization of the industry has also slowly but surely been more of a trickle than a flood. So if you look back at the diagram from McKinsey's data, we can see that offsite construction and digitalization have been coming to the construction industry, at least in the US and abroad, and have not necessarily, in all cases, delivered on the productivity promise. So we keep dropping in productivity despite of CAD arriving in construction in the industry in the 80s, CAD-CAM in the 90s, and BIM most recently. So the tools are out there, but we're not getting the results we need. And so one of the reasons that ModX thinks, and McKinsey as well, thinks that that is the case, is we haven't done our homework. We haven't changed the context for the CONTECH to play a little game on the term. So we haven't, in the US and abroad, changed regulations, contracts, the supply chain, even before the pandemic and the war in Ukraine has suffered. On-site construction is still an issue, and skilling workers is something we have not done. We have jumped to technology often without doing our homework, and have not seen the results that off-site construction can deliver. So what we've been doing at ModX is we've worked with the industry, particularly in the US and abroad. The Modular Building Institute, which is the largest trade association that represents off-site construction in the US, engaged us to develop a strategic plan for them, actually as early as 2016. And that's helped them. We've worked with companies and with NGOs individually. And most recently, we have been working with the federal government, the US Department of Housing and Urban Development, which is essentially like a Ministry of Construction or Housing in Lithuania or in most European countries, to develop research priorities for how to overcome the barriers to offsite construction. Those barriers are primarily contextual. They include a regulatory framework, they include standards, finance, project delivery, workforce, as well as business models. So we want to do our homework. We want to get the context restructured so we can start to see both the digital tools and the hardware that exists, that is already commercially available, deliver on that promise. But to also do that, and what I'm going to talk about briefly today, and this has been our focus with clients, as well as with our sort of education in this year, is to also talk about how we need to rethink design more broadly for construction, if we are to see the benefits that other industries have gotten from digitalization and from industrialization. And so to rethink that design, we've looked to other manufacturing industries, the automotive industry, the IT industries that are investing heavily in offsite, at least in the US and elsewhere, and looked at the tools and concepts that they have developed over the last 100 years that have brought them that kind of productivity increase and have allowed them to use technology in an effective way. And most broadly, we can say that the key concept in manufacturing design is modularization and the development of something called product platforms. So I'm going to briefly define what those concepts are, and then show some examples of how they have successfully worked in construction. So actually borrowing from a great Swedish website on modular management, not specifically in construction, modularization is defined as the activity of dividing a product or system into modules that are flexible, so that they can create different requested configurations while reducing the number of unique building blocks or module variants. By reusing module variants across multiple configurations, an economy of scale is reached without standardizing the product. Product platforms are a collection of modules that are common to several products. This commonality is developed intentionally to achieve desired effects. And you can think of a product platform as a game with a finite but flexible set of playing pieces like Legos or dominoes. Product platforms are not products, and modularization is not productization. We can talk about that more. And then for us to sort of summarize, as ModX, product platform enable economies of scales, not because of the standardization at the product level, but because of standardization at the module level to allow for more variety at the product level. So we have seen this very successfully play out in companies like Apple. In fact, we had a panel a couple of days ago as part of the Modular Building Institute's yearly meeting, where we invited an Apple former vice director for supply chain management to explain the principles to construction, to manufacturing, and to design professionals, and really talk through how these concepts are essential. More essential than necessarily the software or hardware to allow for Apple to provide enough variability and enough standardization for the kind of products that we want and we need. I'm not going to go through this in detail. What's also interesting, the automotive industry is, again, another good example of this. So for example, we know that Tesla has been developing electric cars. And that's very innovative, but for true disruption in the automotive space, we are expecting to see that those kinds of technologies will be adopted by everyone in the space, and they are. That's the exciting thing about what's happening in automotive. So Volkswagen, for example, group has been able to incorporate electric batteries into their cars, into their product platforms very easily because of the principles they use. They have not had to redesign the car to incorporate this new technology. They've been able to apply it to all of their brands. And in fact, they've been able to sell this IP to a competitor, to Ford, who is also using this technology. And this is because their products are designed and conceived in a different way. Understanding sales, understanding supply chain, it's something that we lack in construction. And it's something that is going to prevent us until we change from actually seeing benefits from the hardware and software that exists. So to be more positive, we can look at examples of how these principles abroad and internationally have had success in some contexts. So if we go to Japan, you can see factories of homes that look and operate like an automotive facility. One of the largest companies that we've visited many times and brought experts to, Sekisui Chemical in Japan, in Tokyo, actually have 8 factories focused on both single family and multifamily. Operates a factory that really operates like an automotive factory. They produce 14,000 homes a year, 500,000 homes since the 1970s. And they really have applied and successfully adapted these principles to construction. It's taken them a long time, though. Their parent company, a plastics company, decided to get into the construction space, to move downstream around 1960. Their first attempt was to develop a plastic-based house. It was a disaster. It literally burned up. 10 years later, they tried again and moved into volumetric construction. And for 10 years, the parent company lost money. And in the 1980s, finally was able to develop a manufacturing and sales logic that started to grow and has continued to grow over the last half century. In the 1970s, they developed a product platform, a set of components, but also a set of processes and relationships within the Japanese supply chain that has essentially guided that process for half a century for 500,000 homes. Every component and much of the technology has changed. The relationships have stayed the same. Like the Argos in Greek myth, the ship that sailed for many years and returned to the same port. It wasn't the same ship, even though every component was different. So they've developed a light gauge steel system in the 1970s and even a light wood system in the 1980s, both of whom are able to exchange components from one another, who are able to grow, and who are even able to, like Volkswagen and Ford, share in the technologies that other Japanese companies have developed. So Sekisui offers as many as, I think, 11 lifestyle brands. These are not models. Every floor plan is different. Yet the sales experience feels like purchasing a high-end car. At the same time, it also feels like working with an architect, and the client gets the kind of customized experience that they want, but they get something that they don't get in the construction space, which is predictability. They are guaranteed housing delivery on a day, to the day. And they've done this by standardizing, by, again, understanding what the customer wants, the degree of variability the customer wants, and by standardizing the offerings. So they have 90 pre-engineered chassis, structural chassis. They have 60,000 modules or subassemblies in their system managed by proprietary BIM software, which has evolved with this system. That, again, allows them to balance changes in the supply chain, changes in market needs. And their factories are designed like dry assembly factories. They have 8 factories that service all of Japan. Each factory produces as many as 3,000 to 4,000 homes a year. And those factories, as much as possible, leverage the supply chain of Japan so that as many components as possible are actually not produced by the parent company, but are managed, inspected, and then assembled in these plants. So that's Sekisui, really a good model of understanding how these principles play out. Another benefit of this, which is a new benefit, but one that's going to be, I think, important in the future, is that for Sekisui Chemical, this product platform approach has not only increased efficiency, it's allowed them to address circularity. So they have constructed a new business model around essentially recycling the homes, offering services to their clients, or buying back essentially the chassis from their clients, reusing those chassis and producing new buildings. Closer to Lithuania, just across the water, and I know there's some strong relationships with the industries. In Sweden, we've studied Lindbäck's BIG, a volumetric modular company in Sweden, focused on multifamily and multi-story buildings. That uses similar principles in a different market sector and different context. So again, a forestry products company in this case, not a plastics company, that moved from forestry products downstream into single-family housing in the 1960s, and then volumetric housing, multi-story volumetric housing in the 1980s. So gradual process, slow and steady, developing a kind of an approach that really used the same modularization principles that we see in Japan. So what Sekisui has done, what Lindbäcks has done is taken essentially an American approach to volumetric construction and an American form of construction, the light frame construction, and really, again, further modularized. So in the US, we have a large volumetric modular industry, but the primary component, the key module, let's say, is the volume. And that creates serious problems in terms of standardization of the factory layouts, and also in terms of floor plan flexibility. In Sweden, Lindbäcks and other companies have taken this system and have further modularized it. While these components are shipped as volumes, as finished volumes, the key component for Lindbäcks and for many other Swedish companies is the panel, is a closed panel system. So understanding the grain at which we standardize is a key part of any industry. What is the module? So again, on the left, just quickly an example of a US volumetric project where the modules are all different and the layout is fairly constrained. On the right, a Lindbäcks example where what is standardized is the panel, not the volume. The volume is the unit of shipping and allows for, again, higher degrees of floor plan flexibility and higher standardization within the factory. So the system there, again, is based on highly standardized panel components and highly variable volumes. Another important lesson here, and again, reinforces this idea of modularization preceding digitalization, is that Lindbäcks really developed, again, gradually over time, adopted technologies within its process. And so their main facility until relatively recently, until about 5 years ago, for 20 or 30 years, was essentially an adapted forestry products factory that was optimized to a new product, to volumetric modular. Those systems were developed. That technology was experimented with, optimized, before a purpose-built investment, the new factory that maybe many of you are familiar with in the north of Sweden that Lindbäcks opened in 2018, really operates at the kind of highest level of technology, but those processes have been developed. The kind of analog organizational techniques were optimized, digital and hardware were deployed, and now we really have this kind of this synergy that is really needed to get the kind of productivity benefits from technology. So here's Helena Lidlow, formerly the head of R&D at Lindbäcks, touring us around their former plant at a key moment when their lean management system was moving from an analog system with some digital tools to a fully digitalized system. And the lesson there to learn is that that digital data culture was built in an analog way before the software was developed, before the software was fully applied. And that synergy, that company culture, really made that digital tool work, really made that digital tool deliver. So we are seeing, just in kind of as to wrap up, we have seen in the US at least, a slow and steady attempt to adopt these principles, sometimes not slow enough. So you're probably familiar with Katera, sort of glorious failure. Nevertheless, Katera tried similar principles, those sound principles, and essentially expected to apply them too quickly. And so still a lot to learn from. We're unpacking the lessons of Katera. A small company near me in Boston, Bensonwood Unity Homes, has adopted the same set of technologies at a smaller scale over a more gradual period and have been very successful. Connect Homes is another company that we've followed and worked with. It's a Los Angeles-based small company whose CEO actually comes from Apple. So we had a conversation with him and have been adopting, again, some of these principles, very similar approach to the Japanese process in an analog way, gradually moving towards increased digitalization, increased automation over time, and really balancing, again, that kind of the demands of customers for variability and the demands of the manufacturing process for standardization. And what MODEX likes to do is to enable those knowledge exchanges and to grow the industry. So in 2019, before the pandemic, we took a small group of experts to Japan. We have a good relationship with Sekisui. At that time, Katera was still operating. We were fortunate that Lindbäcks, Helena Lidlo from Lindbäcks joined us. And a small company at the time, volumetric building companies, BBC, also joined, as did Polcom, a Polish company that has been producing a lot of Citizen M's. And since that time, BBC has acquired Helena. She is now the chief technical officer of that company, and has also acquired Polcom, as well as their facilities. And so we are seeing in the US, particularly in a company like volumetric building companies, those lessons and those techniques coming into the US sector. So this is a model, photo of a model of VBC's newly acquired former Katera plant. I know it's a little complicated. And an analog model that is preceding the digitalization and automation techniques that they're going to be applying to their facility there that Helena has organized. So in conclusion, CONTECH needs context, and modularization, these concepts precede industrialization. So we need to understand context before we apply these technologies. We need to understand the business models that we're considering. We need to adopt in construction the same techniques, the same design language, the same design principles that have been successful in other industries if we expect to see the productivity increases that digitalization and automation can bring through technology. Thank you very much.
Thank you, Ivan. I hope you can hear the applause.
Yes.
All right. So we have one quite specific question from the audience. It's how long does it take for Sekisui to develop their system, and what could be improved to repeat it faster?
Well, so that's a great question, and it's a great sub-question, and I know why we all don't want to wait 50 years. So it's interesting, the Sekisui system, this is what I was trying to allude to, and I'd love to talk about this more. The initial product platform, the modules, the concepts were developed in 1971. And if you look at that strategy today, many of the principles are still in play. So essentially, that strategy was sound. It has proven to be successful. And it has continually improved. That's a term, right, that manufacturing industry used for 50 years by both being disciplined, sticking with a broad strategy, and also being open to changes in supply chain, changes in customer demands, and in the knowledge that you're producing. So a complicated way to say it is that the key elements were essentially developed relatively quickly, and then that knowledge process never stopped. Just like it never. So the reason that Apple sells us iPhones is because we are actually literally contributing to their R&D. Right. And this is something that was confirmed to me by many of my colleagues at Apple. We are, by purchasing, using these products, we are essentially contributing to their development. And that's something we don't see in construction. So we can do this relatively quickly, but we need to understand that there is no end to the continual improvement process.
Okay, and I have a personal question. Maybe I'm not hitting, the topic, but if we talk about mass market, so most of the industry sectors, they're going the individualization way, and when we talk about modularization, this is something seems to be opposite way. Is it?
Not at all. That is incorrect.
Okay.
So modularization is not standard. It's not necessarily repeatability. It's not productization. Really, it's about understanding all of the processes, all of the things that go into one of our products, and particularly key in housing. If we want to be able to understand how much variability we can offer a customer within a particular cost range. So, for example, Sekisui Chemical, no two homes are the same. Currently, the original product and the original system was highly repeatable. Over time, that continual improvement allowed them to understand what a consumer is willing to spend, right, and what they're willing to vary, and it's actually increased in variability. Their assumption was that it would be less variable. And that, I think, was a smart place to start. We've seen the same thing across the board, where successful companies start with essentially a market segment, focus on what their supply chain can support today, and then very carefully, through this use of constant feedback, vary it. And often what happens is that those systems become more variable. The degree of variability that we assume, particularly in housing, and I know that's as an architect, I know how much of a minefield it is, particularly single-family homes. Everyone assumes that we have to customize everything. And if you're able to provide your consumer with real cost data, with actual decisions that they make, which will impact the quality, the speed, and the cost, you will very quickly get a much more informed consumer, and one that understands what the value you bring. So in Japan, for example, just to give you an example, they, the tagline at Sekisui is that it's only 8% more than conventional construction. Because, and why is it only 8% more? It's higher performing, and they can prove that. It's more variable than a typical spec builder, and it's delivered on time. So they know their customer, and they know what they can offer, and they know how much customization that customer wants. We speculate on it, because construction is not a data-rich, knowledge-based industry today. It needs to be.
You made it clear for me. Thank you. Okay, thank you, Ivan.
Thank you, everybody.
Bye-bye.